We'll close out today's lecture by talking about how lists are represented in the frame. Why am I doing this? I'm showing you this on one hand to kind of show you how Python Tutor is going to represent these lists, because I'll be using Python Tutor quite a bit this semester, and I hope you'll use it as well to debug your code and figure out what code does. I'm also doing this secretly to hint to you what's going on deep down. This stuff, we're not ready to talk about in the intro to computer science class about how memory, like deep down, really works. But everything that Python Tutor shows you is real, and there's a reason that it's there. And so I won't focus on the details of explaining exactly how the memory works and everything, but I will point out what's important in the way that Python Tutor shows you how lists behave. And this will hopefully give you some insight to solve problems more easily and understand what your code is doing more easily. But I will say, don't forget these things. If you see something weird and you're just curious about what's going on in Python Tutor, you can feel free to ask me on Piazza, and I promise it'll also be explained in later CS classes. So lists are the first kind of more complicated data type that we're seeing. And because they're more complicated, they actually get treated differently than the previous data types that we learned. Our previous data types were always written in the box right next to the variable. Whereas now, because this is a more complicated data type, it actually gets written down separately over here under objects. And the variable we see has this arrow that points to this list object. The way I want you to think about this is just think of it as, for these more complicated types of they get written down on a separate special sheet of paper that's just for these complicated types, these objects. This is over here. And you'll see that as you look at code in Python Tutor and look at these frames, you'll see that when you make a copy, for example, like by slicing, this copy will show up as a new list. That's how you can tell that it's a copy, because num's part points to this new list. It doesn't point to the same list, just to a subpart of it. It points to a brand new list with these 3 items in it. So that's how we can see that it's a new list, it's a copy, different from the previous list. There's an interesting implication here that I want to point out, and that will come up more in the next few weeks. You'll notice that when you pass a list into a function, so because each of these list variables is actually pointing to this object, the object is somewhere else, the list itself is kind of on a different special page for these complicated types. That means that when you pass a list as an argument into a function, you're actually pointing to the same exact list. Like that list exists on a page, and in the local frame, you have a new variable, but that variable refers to that same list that was referred to in the global frame. What this means is the mutations that you apply to that list within the function actually persist. Like they are changing the actual list that's written down on that special page, and so any later code that uses that list will see those changes. So what am I talking about? Let's just look at this particular example. First, you create a number list, and you can see this creates this number list variable and creates this list 427. And this number list just has a little arrow pointing over to this list. But then when you call the add number function and you give it the number list and the number 12, you can see how the 2 variables in this function, the 2 parameters, are nums and x. And because nums is being given a list, and this is this complex data type, it points to the same list. So it's the same list somewhere on this special sheet of paper. And our nums variable is pointing us to that same list. And so in the body of our function, when we do nums.append x, so here x is 12, you can see how 12 gets added to this list. Go from not having it to having it. And now when you get to the very end and you print number list, not inside of the function, out in the outermost layer, we look up the value of number list in the global frame, and it points to this list that had its value updated. And this is interesting and important, and we'll talk about it more as we keep learning more Python. And I just wanted to come and wrap up this lecture with a quick example here in Python Tutor. We'll just say some numbers equals 5, 7, 2. Now we can make an exact copy. Numbers copy equals numbers just colon. And this worked for strings too, remember? Because when you leave out the start index for the slice, it assumes that the start index is 0. And when you leave out the end index for a slice, it assumes that the end index is the end of the sequence. And so here, this will make an exact copy of our numbers. And so if we make any changes to numbers copy, say we want to replace the first value with 100, then numbers, if numbers copy 0 is equal to numbers 0, the same. Let's print they are different. So let's see what happens here. If we come down and visualize execution, the first line gets executed and numbers 572, you can see the list gets created here. The second line gets executed and we make a copy of that list because we're slicing. And now in the copy, we replace index 0 with a 100. So it goes from 5 to 100 in index 0. And so now when we go to look up the values in our two lists and compare them, well, I have a little typo here. Numbers should be numbers. Going forward to line 6. Now this condition is false, and so we go into the else case, and our code prints they are different. So that's it. I just want to repeat and highlight for you. I don't want you to take away how complicated what's going on here is, what are these arrows and all this stuff. I just want you to take away noticing how you can tell in Python Tutor whether something is a different list or the same list. That's it for today. I'll see you in class on Wednesday. Bye.